welcome to class. Today we're going to do lesson 6-4. That's prove triangles are similar, and we're going to prove them similar by the angle-angle similarity postulate. So our goal here is we're going to use the angle-angle similarity postulate. That's what we want to do. So this postulate, the angle-angle similarity postulate, says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So looking here, we're just going to use this postulate. Determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. So we first know that there's two angles that they have in common. You can say angle D is congruent to angle G, okay? And we know that because it's given. I know that the three angles of a triangle have to add up to 180, and because this is a right angle, I know that these two angles, other angles, have to add up to 90. So to find this one, I can say 90 degrees minus 64 degrees, and that equals 26 degrees. So I know this angle is 26 degrees. So we can say angle K is congruent to angle C, and that also is, well, it's not given to us. We just know it's true because the angles of a triangle add up to 180. So we know angle K is congruent to angle C. And so we can say triangle CDE is similar. And just do similar, we just do this kind of squiggly line here, is similar to triangle KGH. And we know that by the angle-angle similarity postulate. Spelled it wrong there. Alright, let's look at the next one here. Example 2, triangle RTV. So we're talking about this triangle right up here. And triangle RQS. So triangle RQS is this larger triangle here. Do you notice they share angle R up there? We want to prove that these are similar. So we can say angle RTV is congruent to angle Q, and that's because it's given. We're told they're both 49 degrees. We can say that angle R is congruent to angle R, and that is because of the reflexive property. Okay, and that's this angle right here. So they both share that angle up at the top. They both have a 49-degree angle. So we can now say triangle RTV is similar to triangle RQS, and that's by the angle-angle similarity postulate. Let's look at this next one. We want to prove that these two triangles, triangle SQR and triangle UVT, we want to prove that they're similar. Well, they both have that angle right there, and that's because they're vertical angles. So we can say angle SVR is congruent to angle UVT, and that's because they're vertical angles. Now if you notice, we've also got parallel lines. We've got these two little triangles that are showing us those two lines are parallel to each other. So as soon as you see parallel lines, you should start thinking, do I have alternate interior angles? And you do indeed. You've got an angle here and an angle here. This is my transversal. Those two are alternate interior angles. So we can say angle R is congruent to angle T, and that's because they're alternate interior angles. We got two angles that are the same now. We can now say triangle SVR is similar to triangle UVT, and that's because of the angle-angle similarity postulate. Alright, let's look at the next problem here. Indirect measurement. Indirect measurement is just a way to measure something that's out of your reach, and it's by creating triangles for it and something you know the measurement of. Thus, we're creating similar triangles to make proportions. So this is something that's a common problem. You'll see problems like this often. So example 3, you stand in the shadow of a tree so that you're 20 yards from the tree and your shadow is 16 feet long. If you stand 6 feet tall, how tall is the tree? So I'm going to draw a picture. We really need a picture. So here's my tree, a beautiful tree, and this tree's got a really long shadow. Okay. And then one thing that's understood here, it says you stand in the shadow of the tree. And so what that means is that you're standing right here in the tree shadow. And your shadow is actually ending at the same spot that the tree's shadow is going to end at. Okay? So we're standing in the shadow of tree, and of the tree, if you notice, now I've got 2 triangles that I can make. Got this larger triangle for the tree, and then I've got this smaller triangle for the person. So I've got 2 similar triangles that share that end down there. Now let's put some numbers to these. So it says you're 20 yards from the tree. So this distance from you to the tree is 20, and that's yards. Your shadow is 16 feet long. So this distance of the shadow here, that is 16 feet. If you stand 6 feet tall, so this side length right here is 6 feet. How tall is the tree? So we're looking for this side. Now, first thing I notice here is I've got yards and feet both. You can't use different measurements. We need to have the same thing. So I'm going to change this 20 yards into feet. So if I just multiply 20 by 3, because there's 3 feet per yard, this is actually 60 feet long. So now I can make my proportions. The height of the person is 6 feet. Over their shadow is 16 feet. The height of the tree we don't know, that's x. And the shadow of the tree is the 60 feet. Plus, you've got to add on the shadow of the person because they're sharing that end part. So it's 60 plus 16, which is 76. So now we can use the cross products property. So I have 16x equals 6 times, well, 60 plus 16 is 76. So let's solve this problem. I have 456 equals 16x. Divide both sides by 16, and x equals 100 and, oops, I'm looking at the wrong thing. X equals 28.5, and that unit is in feet. So x equals 28.5 feet. So this is an example of indirect measurement. Let's look here. It says a lifeguard is standing beside the lifeguard chair on a beach. The lifeguard is 6 feet 4 inches tall and casts a shadow 48 inches long. Their chair casts a shadow that is 6 feet long. How tall is the chair? So if you notice we've got all different units here, I'm going to change them all to feet. I know my answer, to inches, but my answer should be in feet. I'm going to make everything inches though, so my final that I get, I need to divide by 12. So 6 feet, if I multiply that by 12, that is actually 72 inches. So I'm going to use 72 inches for that one. I've got 48 inches here. 6 feet, 4 inches. Well, 6 times 12, and then adding on your 4 inches, that gives you a height. This guy's height is 76 inches. So now I've got all the same units. I can make a proportion. So 76 out of 48, the guy's height over his shadow, equals the chair's height, which we don't know, x, out of the chair's shadow is 72. So we're going to use the cross products property here. 48x equals 76 times 72. So I have 48x equals 5,472. Divide both sides by 48. And x equals 114. And that was in inches. But remember, we wanted our answer over here to be in feet. So I'm going to take my 114 and divide it by 12. And that gives me about 9.5 feet. So my answer is about 9.5 feet. B says in the above example, how long is the shadow of a person that's 4 feet 9 inches tall? So you need to go through, rewrite your triangles, redraw your people, remembering that the height of the chair we've now found that's 114 inches or 9.5 feet. So pause the video and try this last one on your own. Okay, welcome back. You should have found that the height of the shadow, it says how long is the shadow of a person, is going to be 36 inches, or you could have said 3 feet. All right, this is the end of lesson 6-4. Remember, if you had any questions at all, make sure you star them so that tomorrow in class we can go through questions and make sure you really understand all the problems. Have a great night.